So Go is kind of cool because you could create your own types, and the types you create, will have an underlying type. But yeah, create your own types, which is kind of cool. So let's look at the different types, and eventually we'll look at creating our own types. So int, float, string, rune, bool. We're going to learn about length, concat, string conversion, assertion, math, rand, and docs. So int, we all pretty much know that. Floats, we know that, right? One interesting point that's made in the bootcamp videos is just floats are imprecise. I guess I'll actually talk about that in a slide. So you can't use them to keep track of like bank account numbers. Strings, runes, bools, I'll use the slides here. So Go is statically typed. So languages like JavaScript are dynamically typed. This is a big difference between Golang, which is statically typed, and other languages that are dynamically typed. Strong typing, static typing helps prevent errors. Anybody want to define static typing? How would you define it?
All the errors are checked at compile time.
Yeah. So everything's checked at compile time. And dynamic typing, how would you define dynamic typing? It's the opposite of that, right? Yeah. And dynamic typing is also, I think about dynamic typing like JavaScript is like I could just change what it's assigned to. I'm not sure if that's correct or not. Is that correct with dynamic typing?
Yeah.
You can change it anytime.
One description I heard of dynamically typing and statically typing is that in statically typing, the type is attached to the variable name, whereas in dynamic typing, the type is attached to the value.
Yeah. A language is statically typed if the type of a variable is known at compile time. This is in practice means that you as a programmer must specify the type each variable is. The main advantage here is that all kinds of checking can be done by the compiler, and therefore a lot of stupid bugs are caught at a very early stage. Language is dynamically typed if the type of a variable is interpreted at runtime. This means that you as a programmer can write a little quicker because you do not have to specify type every time. Example, Perl. So here I'm using %t, formatting verb, to print out the type, and you can see that's int. So we're going to look at some of the types here. And here I've got int, and I could also print out the type using the reflect package. So %t, line 10 and line 11 do the same thing. So that's a reflect package. And here's float 64. And here is F name and last name, and they're both strings, so I could use double quotes or backticks for strings. And then we get to runes, and so on line 9, you can see I'm using single quotes, and that's basically, I think of it kind of like a character, right? But it's a rune. And so a rune is kind of like a J.R. Tolkien thing a little bit, like people who read Tolkien, a bit of a geeky thing. And, right, talks about runes and J.R. Tolkien. And basically, the definition of a rune is a letter in an alphabet or a character or a symbol. So that's pretty much the same thing, rune or character, right? And let's see, when I run this %t in typepub, it tells me it's an int32. Well, that's kind of interesting, right? And if I go and I look at what is a rune in the language spec, it says a rune is an alias for an int32. And then if I read about this, right, in the spec, what are runes? A rune literal represents a rune constant, an integer value identifying a Unicode code point. A rune literal is expressed as one or more characters enclosed in single quotes. Within the quotes, any character may appear except new line and an unescaped single quote. A single quoted character represents the Unicode value of the character itself, while multi-character sequences beginning with the backslash encode values in various formats. So basically it's our characters, and it shows us the number, and that's the code point in Unicode. And so the code point in Unicode's 32-bit coding scheme, 4 bytes, and the number of bytes used varies. And so the first 127 code points are ASCII in UTF-8 in Unicode. So you can look that up, and you can see hey, whatever this value was, right? If we printed out the value, we could look that up and see what character it referred to. Room is an alias for int32 because UTF-8 is 4 bytes. So here we have int32, and I'm printing out, the rune is it's printing out 100. So if I looked up 100, D in an ASCII table, right, is 100, lowercase 100. Everybody follow? Yeah? Too slow? Raise your hand. On the edge? Too fast? Raise your hand. All right. Don't let me bore you. I don't know what your guys' other classes are like. So here I'm looking at, bool. So we're just looking at types. We saw int, we saw rune, now we're seeing bool. Pretty straightforward. We've seen bool, we've seen numeric, we've seen string. Right? So you know what makes a string, you know what makes a rune, you know what makes bool and numeric. Boolean types, straightforward. This is kind of cool in the documentation. Here, this is the language spec. There's a set of pre-declared numeric types with implementation specific sizes. So uint or an int are going to be either 32 or 64 bits, depending upon your CPU word size. Right? So if you got a 64-bit processor, and you use uint or int to define variables, then they'll be, int 64 or uint 64. When I first saw this list, I was kind of like, what the heck? That's a whole lot of stuff to choose from. Just use, let it be the shorthand assignment, : equals, and then it figures it out for you. Or use int and float 64. Or uint. What's the difference between int and uint? How many people don't know that? Difference between int and uint. Raise your hand, you don't know that. Okay. Everybody knows it? This game's called The Truth Will Save You. So if you don't know it, raise your hand and I won't call on you. If you don't know the difference between int and uint, and I won't call on you. All right, the gentleman in the back left corner with the dark blue shirt on, who's looking at his iPhone and not even tuned in. The gentleman in front of him with glasses on. What's the difference between int and uint? Yeah, you. Yeah. What's the difference between int and uint? Gentleman in front of him. Difference between int and uint. No? You didn't raise your hand, though. I wouldn't have called on you if you'd raise your hand. The game's called The Truth Will Save You. If I say, all right, let's play it again. The game's called The Truth Will Save You. If you don't know the difference between an int and a uint, raise your hand, and I will not call on you. Raise your hand, and I won't call on you if you don't know the difference between an int and a uint. All right, well, there's obviously a lot. Gentleman in the red hat, int, uint. What's the difference?
Int is a signed integer, int is an unsigned integer.
Yeah, perfect. And unsigned, int means it's going to be positive and negative, and so you only have so many, like, if you're storing a byte of stuff, you've got 256 things you could encode, right? Well, if it's signed, well, then we could do 128 on the negative side and 127 on the positive side and include 0. And that's it. Those are the only numbers we could represent with that byte. But if it's unsigned, we could go from 0 to 255, right? And so we could go up a little bit more positive. And so that's the difference between int and uint. So it stands for unsigned. So there's no sign like a negative. You're not showing the negative characters. That's word size. And then we have strings. And a string is a series of characters. It's UTF-8 encoding. ASCII is a 7-bit character series. The first one, 128 letters. And UTF-8 are those same 7 bits, multiple bytes for other characters. UTF-8 is a multiple byte character encoding. Other characters could be 2 bytes or 3 bytes or 4 bytes. Chinese characters will probably be 4 bytes per character. Golang uses UTF-8 because Pike and Thompson were inventors of UTF-8. To create a string, you could use double quotes or backticks. We know that. Backticks can be multiple lines. And we can escape sequences like \n or \t. N for new line, T for tab, similar to other stuff. And here are the other escape sequences from the language spec, but \n and \t are, very common ones. I've never tried alert bell.
It doesn't work on most programming languages. I think it was for back in the DOS days when they actually had a PC chip that whistled at you. It would whistle when you hit
That little speaker add-on on the inside.
But yeah, modern computers don't have them anymore. So
That
They have
sucks.
the pins for them. They just don't ship them with it.
So here are escape sequences. Doot doot. And string types, sequence of bytes, they're immutable. You could find their length, and they could be accessed with integer indices. So we're going to see all that in action. And so here is, well, that's conversion. Maybe we're not going to see it all in action. So sequence of bytes. So here I'm saying I have a string intro, and it's equal to this thing that Abe Lincoln said that. Is that right? I don't know. You guys don't know. It's not history. Who cares? Format print line intro, right? Print the string. And then I can say I'm going to convert this, and that's conversion. So it's like casting in other languages. But I think Go is like very semantic, right? And use terminology which is precise and evocative. And casting, while that's been in programming for a long time, is in a lot of other languages. I don't know if casting is the best word. Like conversion actually kind of makes more sense. Like I'm going to convert this into a slice of bytes. And so now I can see the individual bytes of each character. F, capital F is 70. O is 111, right? I could see that. And here's the ASCII table where I could look it up. So decimal 70 is equal to capital F. 111 is right here, and that's equal to O, and that's O. Right? So when we see that a string is a sequence of bytes, it's literally a sequence of bytes. And we can see that sequence of bytes. It's immutable, so you can't change it, right? You could assign something new to a variable, but you can't change the thing. Find the length, and you can access any of those letters by an index. So let's see if I got the index thing. I like the index example. Where is it? There's length. Okay, so we do get to the index, so let's see it. So here, playing with immutability, it seems like I changed a string. I don't know how to prove immutability. I was trying to prove immutability here, and I couldn't get to prove. So that's my challenge for you guys. Prove immutability if you can. Just bring it back and show me on Thursday. Like, hey, I proved immutability. This is my attempt, and I don't feel like I proved it. So here's length, and length gives us a number of bytes. So length of that, yeah, 5 bytes there, right? Makes sense. Length of this, 6. Because many bytes make up Chinese characters. So that's kind of funny. So, just know that if you're building global apps. And here we have an index where we're getting the first character G72 or the fourth character 0, 1, 2, 3, 4, T, fifth character, sorry, 111. 111, lowercase o. That's not right. Lowercase o.
No, it's hello.
Hello. I'm doing it hello, not greeting. Thank you. All right. I think it's interesting the index shows you the byte. It doesn't show you the letter, right? It shows you the number, the decimal number. I think that's interesting. What is this going to print?
Yeah.
What the hell did that just do? Right? And so there I'm slicing. So there's a difference between getting an index, which is just like, hey, show me the character of this one position, the decimal representation of it, and slicing. So that's index, no colon. This is slicing. You include a colon. And so slicing is, other languages have it. For the people who've done Python, it has it. And so here's some of the ways you could slice and some of the output. So you can kind of play with that, right? And just see what the slicing does. But colon is slicing, which is different than taking an index, which is different than a slice. So a slice would be like a slice of bytes. It's a list. And then we have slicing, which is like cutting something up. And then we have an index.
I find slices is easier to understand if you move the numbers over a little bit so they're in between each character. And that way you can clearly see it's from there to the...
Oh yeah, have these come over a little. Yeah, so this is from the beginning to 4, 0, 1, 2, 3, 4, and but not including the last, so the last one doesn't get included. You could also write it exactly the same way here. This is from the first character. The first character does get included, E, and it goes up to the fourth character, but the fourth character is never included in a slice. And I don't know why. Anybody know?
So like I said, it's from the move it over like half a step, the numbers over half a step.
Oh yeah.
That way you can see it's from 1 to 4, where 1 is between the H and the E.
Oh, I
and 4 is
see.
between
I
the
see.
alphabet.
I see what you're doing. Yeah, all right. So you think about it that way. Different ways to think about it. Concatenations, plus sign, you can do that with strings, James Bond. And then escape sequences, length, exercises. The string convert package is good to know about, so you can convert, ints to ASCII or ASCII to int. I think that's what the A stands for in ITOA. Is that right?
So,
That's just my
those
assumption.
are old C functions. I'm not actually sure. They could probably.
And so that's how you'd use it. So I'm taking negative 42, and that's a string, and I'm turning it into an int. And then in the second line there, I'm taking an int, negative 42, and I'm turning it into a string, int to ASCII, I2A. And so here's that in action, hello world plus 5, and it adds that to the end as a string because I use int to ASCII, string convert. And then you can also convert an int to a string like this with sprint, string print. So string print in action will turn it into a string. And
although theoretically the string convert one would be faster because the sprint has to figure out what type it is first.
Dude, I don't know how you know the stuff you know. That's awesome.
It's a microsecond difference, but if you're inside some deep for loop or something, use the proper function instead of the shortcut.
I looked at the source code here trying to see how to sprint do that, and I was just like, oh, that's a rabbit hole. But
yeah, that'll go away.
But Daniel somehow looks at all that and says, oh yeah, no, the other one's faster. So there we got string convert ASCII to int, and then adding. So 42, the answer to the meaning of life. So conversion, so we have conversion, and known as casting in some language, and we're also going to see assertion in a bit. So I just want to make sure we're clear on the difference between conversion and assertion. And one of the things, these slides provide a really good foundation because as we get into other stuff, when you look at things, you're like, what the hell is the difference between conversion and assertion? Well, now you could go back and you can look, right? And you kind of need that to understand what's coming. And that's where a lot of people sort of hit the wall at boot camp, other people, because we went through that stuff so fast that then people are like, wait, now what? And there's a benefit to that because, as you get pulled along, right, your understanding might be like 3 weeks behind, so to speak. But by the time you're at week 40, you're like, cool, I've learned up through 37. Don't understand what the hell's happening to this week, but I know I finally get last week 3 weeks ago, right? Understand that. But two roads, maybe the same flat path. So conversion, known as casting in some language, are expressions of the form tx. So when you see t in the documentation, it's often referring to like a type. And x, right, is a variable, where t is a type and x is an expression that can be converted to type t. All right, so that's basically what we saw. You can read this on your own. And so here we have an int and a float, and I am taking x, which is an int, and I'm turning it into a float. Straightforward.
One thing to note is that casting in other languages is a reinterpret how you're reading it, whereas conversion here in Go is actually make a copy of it as this type. So little difference in the end, but it does get used to a little more memory, which that's usually not your blocking factor in your programs.
Cool. And here's the opposite, making float init. And x rune is A. Rune is an alias for int32, and y is an int32b, and we print each of those. We get 97 and 98. And then what are we doing there? Conversion, making them strings. Conversion rune to string. Kind of interesting. This could have been both rune or both int32, right? Those are just kind of numbers when we put the single quotes around them. And here we're taking a string of a slice of bytes, and we're making it a string. I don't know how that'd work if you drop Chinese characters in there. You might try it and find out. And here we're taking a string, we're making a slice of bytes. So different conversions. And then here's assertion. So conversion is change one type to another. Is that the right wording, or would you use different wording? Is that what you just said? No, because it's not changing it. No, it is. It is changing it.
Effectively, it's making a copy of it.
Making a copy.
Type.
And an assertion is used for interfaces. So we'll learn about interfaces. We'll learn more about them. But as you gain exposure, you'll gain an understanding. And so we already saw this, where we are doing this thing where we used a switch to determine type. Notice X is of type interface up there. And you can see, we could see the assertion occurring right here, X dot type. Right? This is an assertion. We're asserting that X is of this type. Is it an int? Is it a string? Is it a contact? So that's assertion. So we'll learn more about that. And for an expression of X of interface type and a type T, the primary expression X dot T, the type, right, asserts that X is not nil and that the value stored in X is of type T. The notation X dot T is called a type assertion. So assertions are for interface types. That's the main thing you want to get from this. And here we see another example, var X interface, and this means it could be any type, that's the type right there, is 7, right? So this actually makes a dynamic type. And then we could say that we can assert that X is an int, right? We just know that, and we can assert that, and then we could use it as an int. And type assertion is used in an assignment or initialization of the special form VOK, so you could use this, right? This is the comma OK idiom. And so we could try to assert it, and then we could check, if that's okay, we could do something. And a couple different ways you could write it. So dynamic type, even though Go is statically typed, we can use interfaces to create dynamic typing. So just notice dynamic in here.
This OK format is used is actually used in networking a little bit. A lot of the networking errors that they return have a type of network error, and some do not though. So you use that OK form to see if there's a network error, which network error has got extra methods on it, which are useful for like figuring out if it's a temporary error or something that you could probably shut down about. Where then if the OK is false, that means it's probably a system error, you're definitely going to want to shut down for that.
So here we're trying to assert that value of type interface is a string. And we're saying, hey, okay, if it's okay, then, do something. Otherwise, hey, this isn't a string. So here's that in action. So I'm saying, hey, name is equal to Sydney. Name's not type interface. So when I try to assert name is a string, right, it's like, what are you talking about? This is a non-interface type, string on left, right? Because assertions are only for interfaces. And but if I then name it this way, var name interface Sydney, and I can now assert that name is a string. And it's like, yep, name's a string. So assertions are for interfaces. So assertions versus conversions. It's one of the important things you want to get. So here I'm trying to assert that this is a string, name's a string, but name is actually an int. So if I put int in there, I wonder if that's my next slide. It's not. It would work. Value's an int. I'd have to assert name is an int. So here, val interface 7, and then I print the type of that, and I get int. You can see here.
I get a question now.
Yeah, what's up, Mandi?
Would you go back a slide, please?
Sure.
In line 7, what gets stored in str?
So the actual string would get stored there.
But because it's OK is false, it would just give the 0 value instead.
Yeah.
An empty string.
Oh, okay.
So here the string, just get an empty string if it's false. Here the string, am I printed out? OK, string, and what did I print out here? I did the type of it. So there we go, I did the type, and it gave me string. I can print that out. You can play with the code. I'll play with that some more. Anyhow, we're out of time. So we'll pick this up again right in this area. What, Thursday? Anybody have any comments or questions? How many people learned something new? How many people is good for you today? All right. See you guys Thursday. Just stay in communication with me if you want something different. Whatever, I could just throw you the boot camp videos, and then we could just come in here and talk about what you watched and work on it in class together.
Another 8 weeks. should just say 8 hours a day, right? Yeah, we should just be 8 hours a day.
Yeah, that'd be awesome.